All right. And we're live. Good morning, sixth grade.
Good morning.
Let's see what we got. Good morning.
Good morning.
Good morning. Good morning. Good morning. All right, listen. Here we go. I got Aiden Burnell, Alani, Jesus, Amanda, Angelina, Daniel, Esther, Jazzy, Q, Kamora, Maddox, Eliani, Adrian, Aiden A, Alexander, Alyssa, Allison P, Allison M, Anthony SR, Ashley, Blessings, Daniela, Alani, Haley, Jacob, Jameer, Jency, Kyasia, Kira, Nazir C, Nathan, Mikel, Sarai, Sergio, Steven, Zachariah, and Demi. Good morning. That's 36 students. Thank you for showing up today. So before I go any farther, I just want to shout out last week, and then I'm going to put you all on mute. Last week, you were asked if you submitted all your work for the last 2 weeks to work on iReady. And those that submitted your work were told to work on iReady, and I reached out to you if you were not having any time. I want to shout out a few students that actually put in more time that was required. Even though you might not be on here, that's okay. So here we go. I'm gonna shout you out. In the top iReady students that did the most amount of time in class 601 were Kamaya Kennedy with 5 hours and 49 minutes, followed by Daniela Corona with 5 hours and 26 minutes, followed by Nazir Cologne with 4 hours and 35 minutes. And then Mariah Forrester had 2 hours and 49 minutes. In class 602, we have Aiden Burnell with 3 hours and 57 minutes. Good job. We have Demi that did 3 hours and 45 minutes. We have Nathan Mario that did 2 hours and 36 minutes. And we have Kiana Sutherland that did 2 hours and 32 minutes. In class 603, we have 3 students. We have Janaea Sloden did 5 hours and 30 minutes. Michaelan Scott did 4 hours and 9 minutes. And Carlton Bryan Jr. did 3 hours and 36 minutes. In class 604, shout out to the following scholars for the most amount of iReady time. Blessing, 7 hours and 20 minutes. Jameer Miller, 3 hours and 32 minutes. And Amanda, 2 hours and 31 minutes. Congratulations to all of you. Hopefully this week, if your name wasn't on there, maybe you'll be on there for week 2. Now we're going to actually get started on today's lesson. I don't know why people are on. That's why. Okay, let me tell you what we're going to be working on today. Today, folks, it is, I'm just going to bring me to the screen for a minute. Today, folks, it is Tuesday, May 19th of 2020. And we are going to be working on this packet that looks like mine. Okay? We are going to be working with integers again. Yesterday, we worked on adding integers. And today, we're going to take that skill and we're going to actually apply it with some fractions. So here's what we're doing. We're on page 1. Everyone should have their name on there. And I'm going to read through what we got, model a few problems, and then I'm going to have you folks help me. So good morning, Yair. Nice to see you as well. All right, so today, scholars, we're going to review how to perform operations with rational numbers. This is the beginning of your 7th grade math. So important vocabulary, number 1. A rational number is a number that can be written as a fraction. It has the word ratio. Remember, a ratio is written as a fraction. So think rational, ratio, fraction. Rational numbers are real numbers that can be positive and negative. A number that is not rational is called irrational. Most of the numbers that people use in everyday life are rational numbers. These include fractions and integers. So for example, we're on page 1. Other rules. The rules for adding and subtracting all rational numbers are the same. Classifying rational numbers. We have a number, then we can make it a fraction, and then it's a whole number, integer, and rational number. To make any whole number a fraction, we put the denominator over 1. Now, if we have -7 is an integer because it's a negative integer. It also is a fraction when you put it over 1. When you look at 3 2/5, okay, that is a rational number because it contains a fraction. Remember, rational number is a fraction. So 3 2/5 is the same as a mixed number of 3 times 5 which is 15 plus 2 is 17 over 5. A rational number can also be written as a decimal. So 0.6 is the same as 6/10 as a fraction, because there's 6/10. This is in the tenths place, 6 over 10, which is the same as 3/5. So today, when we see a fraction, we want to convert it into a decimal. So let's look at page 1, page 2, okay? I'm gonna have someone come and read page 2, problem 1, and then I'm gonna model how to do it with you. So let's call this person up to read. Okay, good morning, Esther.
Good morning.
All right, can you read us page 2 in your presidential level 3 volume voice, please, number 1?
Amy, Ray, Kim, and Jamal are on a trivia team. They gain points for correcting answers.
That's right.
Amy, Kim, and Jamal are on a trivia team. They gain points for correct answers and lose points for incorrect answers. During the contest, Amy gains 3 points, Ray loses 4 points, Kim loses 2 points, and Jamal gains 5 points. How many points does the team have at the end of the contest?
All right, so first off, I'm going to help you out. Thank you for reading. I'm going to model this one for you. First off, all right, before you start doing anything, you got to write the word gain, losses, losses, gain on the side. Because the problem tells you someone gains points, then they lose, then they lose, then they gain. Once you have gain on your paper, you're going to go to your first person. So if you look at Amy, a gain, Amy gains 3 points. A gain is a positive integer. So I'm going to put plus 3 here. A gain is a positive integer. Amy gained 3 points. So I'm going to go to my number line, and I'm going to put a closed circle on 3 to represent Amy. A for Amy. Next person. In the next sentence, we see that Ray loses 4 points. So if a gain is positive, a loss is a negative. So under losses, I'm going to put minus 4 because it's a negative integer. Now, I'm at 3 and I lose 4. So that means I got to go towards the negative side 4 hops. So I'm going to take my pencil and I'm going to hop to the left 4 times. 1, 2, 3, 4. This now represents Amy and Ray. Now, Kim loses 2. So loss is a minus 2. So now, if I lose 2, do I go to the negative or positive? I'm going to go to the negative. So the third point, 1, 2 would be at, 1, 2 would be here for K for Kim. Okay, so I was here for Ray, and it says she loses 4. 1, 2, 3, 4. And now it says Jamel gains 5. Gain is plus 5. So I'm going to use, I'm going to go grab something else. I thought I had my little marker kit here. I'm going to use the yellow highlighter to show you 5 hops. Okay, we're going to do 5 hops from the yellow. We're going to gain 5. 1, 2, 3, 4, 5. So if you look, we now stop at 2. So the new amount of points, right, because we were here and we're gaining 5, we stop at positive 2. So the answer is at the end of the contest, the team will have 2 points. Again, I took each person and I plotted it on the number line. So A for Amy was 3. I went to 3. Then I went down 4 spots because that represented Ray. A loss is negative. Then another loss, I go to that answer and I go 2 more to the negative for, I think that was Kim. And then Jamel, which is J, is now going to be 5 to the positive side, which brings me at positive 2. Now, evaluate problem 2. Negative 1/4 plus 4. Anytime we have a fraction, we want to convert that to a decimal. So we divide 1 by 4, or we think, how many quarters are in a dollar? Well, there are 4 quarters in a dollar, and each quarter is 25 cents. So if I have 1 quarter, I now have 25 cents, which is 0.25. And here we put the negative sign. So we're going to convert negative 1/4 to be negative 0.25. We're always going to convert the fraction to a decimal. We keep the negative and we divide 1 by 4. And we get negative 0.25. Now we have to add 4. So we're going to take this and we're going to add 4. Now, here's the catch. Going from yesterday, the rule you have to remember is we have a negative and we're adding a positive. When the signs are different, we take the sign of the higher number and we subtract. So in this case, the 4 is greater or higher than the 0.25. So now, okay, so now what we have to do, okay, is we're going to subtract 4 minus 0.25. So we have to make 4 a decimal by doing 4.00 minus 0.25. Looks like this. And we're going to keep the positive 4 because that's the greater number. Remember, 4 is a decimal by adding a decimal point and 2 zeros minus 0.25. I can't take 0 from 5, so I regroup and make that a 10. This becomes a 9, and that stays as a 3. So 10, 9, and 3. So now when I subtract, I'm going to get 7.3. 3.75 plus 0.25 gives me 4. Which then is going to be about here on my number line. Something like this, okay? It would have been a little difficult to show you that if I divide this into 4 parts, each part's a quarter on the number line. So between 1 and 2, we have 1 and 1/4, 1 and 1/2, 1 and 3/4, and then 3, and then 2. So the answer would be positive 3.75. I am going to do these problems with you just because they're a little tricky. I make you think today. Okay. Okay. I'm going to call someone off, though, to come do problem 3. If you would like to do problem 3, show me the hand, the virtual hand on here. Who would like to do problem 3 on page 3? I got someone to come do it. Okay. Hello, Maddox. You're the lucky one today.
Okay.
Can you read us page 3, problem 3, sir?
Which of the following is equivalent to 4?
Okay, so Maddox, let's look at A. Negative 8 plus 4. We keep the sign of the higher number and subtract. So what do we get?
That's negative 4.
Good. How about for B? When we divide, we keep the, oh, you don't know dividing, sorry. So when we divide, when we have different signs, it's negative, and then divide. 28 divided by 7.
28 divided by 7 equals 4.
Oh, it's negative 4. All right, now think on this one. Same thing when you multiply. When the signs are, you have a negative and a negative, that makes a positive, and a positive times a negative is a negative. So what's 2 times 2?
2 times 2 is 4.
I meant to say 1 times 2, sorry.
2.
And then 2 times 2?
4.
So it'll be nothing is equal to 4 here. Look, I'm sorry, you didn't learn multiplying and dividing. I apologize. It's my mistake. All right, we're going to do that one on tomorrow. So which one of these is equal to positive 4? Is there an answer equal to positive 4, Maddox? Yes or no?
No.
No, so we're going to write no. There's none. That one was a thinking question. And no, it wasn't a mistake. So we're going to put none. Sometimes that happens. Same thing here. We're going to apply. I'm going to teach you how to subtract an integer. I'm going to teach you how to subtract an integer. So let's look at how we subtract. We're going to do this one, number 4 first, though. Then I'll teach you how to subtract. Let's call off. Let's see who we got on here. Let's call you. Hello, Amanda.
Hello.
All right, Amanda, you're going to read for us problem 4, where it says understanding addition of integers, please.
You want me to read the equation?
Yes, please.
-5 plus +3 equals -2. The sum is 3 units to the right of -5.
Okay. So we have -5, right? So we're going to go and put a closed circle on -5. It says that the sum means you add, so we're going to add 3. So if we're going to add 3, Amanda, are we going to go to the left on the negative or to the right on the positive?
The right.
Right, so we're going to hop from -5 to the right 3 times. 1, 2, 3, and what number should you arrive at?
-2.
Excellent. So this is what it should look like. Again, we started at -5, and then it says that the sum of 3 is to the right. So -5, we go 1, 2, 3. Remember, this is the left. Your negatives are on the left, and your positives are on the right. You got to know right and left. Does that make sense so far? Thumbs up. Okay, thumbs up. I saw 1 thumb up. Let me go check the other screen. Okay, I see a lot of thumbs up. Awesome. Okay. All right. So I'm just going to put myself up here for a second. Let me go back to this view. Okay. Oh, no. Hold on. Let me exit. What did I just hit? Oh, no. Oh. Okay. Hold on a second. All right. All right. It looks like I can't do anything. Hold on a sec. Let me hit escape and see what happens. My computer's like frozen. All right. There we go. Sorry, guys. All right. Let's go to speaker view. Okay. All right. Here we are. Let's look at this problem. This is now how you subtract an integer. Okay. When you subtract integers, you're going to keep the first number. You're going to change the subtraction to addition. And then you're going to change the subtraction to positive. So you're going to go keep, change, change. KCC. Keep, change, change. So we're going to write keep, change, change. KCC. Keep, change, change. We're going to keep the 4 sevens. So everyone's going to keep 4 sevens. The opposite of subtraction is addition. So it's 4 sevens plus a -5/9 becomes positive 5/9. So now it's keep, change, change. You're doing the additive inverse. You keep the 4 sevens, you change the subtraction to addition, and then you change the subtraction to addition. You keep, then you change, then you change. Now, if you look here, you notice that the denominators are different. We have unlike denominators. So we got to find a common denominator that both 7 and 9 share. So you're pretty much finding the LCD, the least common denominator, or the multiples. And the common number that is shared between 7 and 9 is 63. So we have to get each denominator to be 63. So now I'm going to make an arrow. And I'm going to write. How do I get from 7 to 63? What operation do I do? I multiply. I'm going to multiply the bottom by 7, which means I got to multiply the bottom by 9, which means I got to multiply the top by 9. So 7 times 9 is 63, just like 9 times 4 is 36. So this is what I did. I went from 4 7, I times the numerator and denominator, both by the same number. So it looks like this. I multiplied 4 times 9 to get 36 and 4 times 9 to get 63. I got to also do the same here to get 5 ninths to be equal to 63. So I'm going to write plus. We got to now do 5 ninths. We know that we have to get to 63, so we times by 7, which then give me 35 over 63, because 9 times 7 is 63, and 5 times 7 is 35. So now I'm going to take the new fractions that have 63 as the denominator, which is 36 over 63, which is the same as 4 sevenths, and 5 ninths, which is the same or equivalent to 35 over 63, and add them up. So again, I now add 36 plus 35 and I get 71, and I keep the denominators, because when the denominators are the same, I add the numerators and keep the denominators. So now this becomes 71 over 63. So we can start to rule out some answers. We notice that 71 over 63 is not an answer choice, but we know that we have to obviously convert. And we know that fractions is divisions because we've been working with it all year round. We know that it has to be a positive number because there is no negative. So we can rule out anything that has a negative answer. So that means I can cross off choice A, choice C, and choice D. There's no way I am going to have a negative answer. I'm going to prove to you why 1 and 8 over 63 is equivalent to 71 over 63. When you do long division, you're going to divide 63 into 71, and 63 goes into 71 one time. 1 times 63 is 63, right? When we do long division. We have 8 as my numerator. 8 goes as the numerator, which is the leftover, and the divisor, which is 63, is the denominator. So it's 1 and 8/63. So the answer would be choice B. Okay? That is what that would be. So please take a moment to write that down. 1 over 63 would be your answer. Again, you have to find the least common denominator, or the LCD, which was 63, because 9 times 7 is 63. Remember, what I do to the numerator, I do to the denominator, like when we find equivalent ratios, right? Whatever we multiply by, we multiply the numerator and denominator by. Whatever we divide the numerator by, we divide the denominator by. It's the same concept here. All right. Now here's what's going to happen. We're going to do this page together. I'm going to call some people to help me out. I already got my first volunteer at hand. Uh-oh. My computer is frozen. Okay. Let me see. Awesome. Oh, no. Let's go to escape and see what happens. All right, here we go. We're going to now work on page 4. All right. Nazier, you're going to help us out. All right. Let me see something here. Okay. Naz, you good?
Yeah.
All right. Nazir, can you read for me page 4, the directions, sir, and the little rules that I wrote?
Practice This problem, page 6, adding integers. Direction, simplify each expression, find the sum for each integer.
Okay, so what do the rules say? Same signs, what do you do?
Same signs, you add, different signs, you subtract.
Good, so circle add and circle subtract. Good job. All right, so you're going to take it away. You're going to do number 1 for us. Can you read it, please? Good job.
-3 plus -17.
So what do we do?
We add.
Add, and we keep the sign. So what is the answer? 3 plus 17.
No, wait, I'm doing the math.
17 plus 3, that's easy. Come on, that's easy. Negative what? We have 17, we add 3. We have 18, 19.
20.
Good, so negative 20. Good job. All right, we're going to call, you're going to go back on mute now. Okay. So Kimora, good morning. You're going to be next. You're going to do number 2. Can you read the problem and tell us what rule we're using? Number 2 on page 4. Kimora, you're unmuted. Speak. Kimora, we can't hear you. Turn your mic on.
Mic is on.
Oh, there we go. Okay. So 5 plus -2. Are we adding or are we subtracting?
Subtracting.
Hmm?
Subtracting.
Okay. So tell us what the answer is. What do we do?
You go down twice.
And what do we get?
+3.
Excellent. +3. I like how you said that. Can you try number 3 for me? -4 plus -4. What do we do? Adding or subtracting?
Subtracting.
The signs are the same.
Subtracting.
So when the signs are the same, we add, right? And keep the sign.
Yes.
So we keep the negative and we add 4 plus 4, which is what?
-7.
One more.
-8.
Excellent. Good job. Thank you, Kamar. Let's go. We're going to put you back on mute now. And we're going to bring her. Jazzy, Q? Guess not. Let's try this one. Hi, Allie M. Allie, unmute yourself. Yeah, you. Unmute. Okay. Hi. Yes, I can hear you. All right, you're going to do number 4 for us. 7 plus -11. Are we adding or subtracting?
We are adding.
Same sign or different sign?
So like subtracting. Basically.
Right. And we're keeping the sign of the higher number, which is what? Positive or negative?
Negative.
Yeah. And what's 11 minus 7?
11 minus 7 is 4.
Good. You're going to do number 5 for me. Good job. Number 5. 4 plus 12.
Oh, that's easy. 12. 17.
One less.
Oh, 18.
4 plus 12 is 1 less than 17.
Oh, 16.
Okay.
My bad.
It's
I'm
okay.
hungry.
It's all right. Go back on mute. Okay. Yeah. All right. We're going to have, bye. Go back on mute. Thank you. All right, Hector. Hector, page 6. You're going to read the question. What does the problem say? The expression. What did I write?
What page again?
Page 4, number 6.
I thought you said page 6.
Sorry, okay. Yeah, I think I did. I'm sorry. So -25 plus 5. Are we adding or subtracting?
Subtracting.
Good. So what is the answer?
-20.
Good. We say that -20, okay? Because minus and negative, we want to be careful. Okay, good job. Go do number 7. Number 7. 8 plus 10. Are we adding or subtracting?
Adding.
Good. What's the answer?
18.
Good. Positive 18 or 18. And last but not least, -1 plus 7, Hector. What are we adding or subtracting there?
Subtracting.
Okay. So it would be what?
-6. Wait,
-6 or +6?
positive.
Good. I'm going to show the responses now. All right. Everyone should be focusing right now. All right. We're almost done. So here's what we got. Again, when the signs are the same, we keep the sign and add. Same signs, we keep the sign and add. Different signs, we keep the sign of the higher number and subtract. Same signs, add. Different signs, keep the sign of the higher number and subtract. I provided the number line for you, but it looks like we didn't have to use it. If you just know these rules, you can answer anything. Take 10 more seconds, where I'm going to teach you something on the extension page. Okay, I'm going to put this down now. Everyone should have had it. All right. Now, this is really cool. We're almost done. We have this page in the exit ticket, then we're done. All right, so here we go. We got okay, on the extension. Here's the trick. If this is the exponential form, it's a base to a power. We know that the exponent is the power raised. So the exponent is going to be that subscript, that number. Okay? Anytime you have an odd exponent, it's always going to be a negative answer. So you don't even have to do the math here. Every time that you have an odd exponent, like 1, 3, 5, 7, 9, it's always going to be a negative product. Anytime you have an even an even exponent, like 2, 4, 6, 8, 10, 12, 100, because they're all divisible by a number, by even numbers, it's always going to be positive. So for example, -1 to the third power is -1 times -1 times -1. -1 times -1 times -1 is going to be a negative number. The exponent would be 3, and the product or the sign is going to be negative. So I don't expect you to sit here and write out -1 100 times, because that's going to be there all day. Just remember, when the exponent is negative, the product sign is negative. When the exponent is even, the product or answer to multiplication is positive. So let's look at here. We have 4 is the exponent. We know that the product has to be positive. So we know that for -4 to the 4th, it's a positive solution. I'm going to call on someone to help me out. Let's try this one. Let's try, where did, let's try here. Let's try you. Esther, can you unmute yourself, please? I gave you a privilege. All right, Esther, we got -1 to the 4th power. How do we expand that out? How do we write that out?
It's -1,
Mm-hmm.
then -1.
Good, and we have 4 of them.
Yeah, 4 times.
Hear her, but
So that means that the exponent is to the 4, which means what kind of product is that? Positive or negative? Remember, odd is negative,
Negative. Wait,
even is positive, right? So let's look at the next one. -1 to the 5th power. We're going to sit there. -1 times -1 times -1 times -1 times -1. Obviously, it's an odd number, so it's going to be -1. There's 5 exponents, and it's going to be negative. So when you have 10 as your exponent, 13, 100, and 101, I'm going to show you a cool trick. So when you look here, we're not going to sit and write out -1 10 times. We don't have enough space. But we know when we have an even product, when we have an even exponent, the product is going to be 1. It's going to be positive. So 10 would be 1 as the product and be positive. I'm not going to have you write it out 13 times. That's silly. But this exponent is odd. So since it's an odd exponent, it's going to be a negative product. A 100 is even. So it's going to be a positive answer. And 101 is the exponent, which means it's going to be a negative product. So what I said here is that when the exponent is an even number, it's going to have a positive, and you're going to write this, product. When the exponent is an odd number, it's going to have a negative product. I understand it was a challenge, but I did want to do that with you. Okay, so here's what I wrote down that you need to write. When the exponent is an even number, it's a positive product. When the exponent is an odd number, like 13, 5, 1, 3, 5, 7, 9, 11, 13, 15, it's always going to be a negative product because of the signs. So write this down. You don't have to write it, expand it out. It's just going to take too long. You can just go like this. Yes, Aiden Burnell. Yes, Aiden Burnell. What's your question about this?
None of us can see it.
Okay.
It's literally blurry. Maybe from the camera, you think?
I will send it to your mom.
Okay.
Okay? No worries, sir. Okay, so remember, even exponent gives me a positive product. An odd exponent gives me a negative product. Okay. I'm gonna call on 1, 2, 3, 4, 5, 6 students now to help me that have not had a turn. And then we're gonna move on now to the exit ticket page. Okay, we're on page 6 now. We're gonna use the number line. All right, Anthony S., how you doing? Anthony, SR? Can you hear me? Anthony? Yeah. Okay, awesome. We're on page 6, letter A, -3 plus 7. Use your number line. Go to -3 and add 7 to the right. Add 7 bunny hops to the right. Tell me what you arrived at.
-4.
-4 or +4?
Positive.
Good. Thank you. We're going to call on somebody else now, so go back on mute. Thank you. You got to, Anthony, you got to go back up here. All right. All right. Let's try you. Hello, Jesus. Jesus, unmute yourself, please. Thank you. Jesus, please do letter B for me. We got 2 plus -5. What do? We go to 2, and do we move to the right or the left?
I really don't understand what this is right here.
Okay, so let's look at it. -5, is that on the to the left of 2 are the negatives, or are they to the right of 2? Look at your number line. We'll help you out. Look. We are at 2, which is here. We want to now go to -5. -5, we have to go to the negative side to the left. So I'm going to take the 2 and I'm going to hop 5 to the left. 1, 2, 3, 4, 5, and we get -3 as the answer. Okay, I'm going to call now Maddox. All right, Maddox. Letter C. We got -1 plus -2. Walk us through. What do we do?
So you go to -2 on the number line and then just add 1. So that would be -3.
Good job. Can you do letter D for us?
It's 6 plus -4. You start at 6 and you go down 4 since 6 is the highest number, so the answer will be 2.
Excellent. All right, I'm gonna call on somebody else to be fair. Thanks, Maddox. Then Melissa, you got this. Letter E, -6 plus 12. So go on -6 and go add 12. There's only one way to go, right?
Yeah.
So you're at -6 and give me 12 positive. What do we stop at? Use your number. Huh?
6.
Good. Go do letter F for me. Start at 0 and add -1. Do we go to the right or the left?
Is -1.
Perfect. See, it's not that difficult, right? Good job, Demi. I knew you could do it. Good job. All right, so this concludes what you should have had. Again, I highlighted the answer in yellow so you can see on the number line what it looks like. That is all you had to do. Very straightforward. You got to use the number line when they give it to you. All right? So there should be no reason that when the exit ticket comes out later on today that you don't get 100 because we just went over how to do it.